Bismillahirrahmanirrahim. Today, we'd like to cover this topic, equations of motion, cylindrical coordinates. So, today's objective, students will be able to analyze the kinetics of a particle using cylindrical coordinates. Why we say this as cylindrical coordinates? If you see in this picture, it is a roller coaster that travel from this point until any point inside its track. It is actually in terms of cylinder shape. You can see another example in this picture. The forces acting on the 50 kilogram boy can be analyzed using the cylindrical coordinate system. How would you write the equation describing the frictional force on the boy as he slides down this helical slide? Okay, you can see here it still give you the shape of motion as a cylindrical coordinates in terms of z direction. This is another example when an airplane executes the vertical loop shown above. The centrifugal force causes the normal force apparent weight on the pilot to be smaller than her actual weight. How would you calculate the velocity necessary for the pilot to experience weightlessness at A? Alright, if you see here an airplane is upside down to execute an acrobatic motion. With certain speed, 24 meter per second, and at A you can actually calculate the apparent weight. Okay, this approach to solving problems has some external similarity to the normal and tangential method just studied. However, the path may be more complex or the problem may have other attributes that make it desirable to use cylindrical coordinates. Equilibrium equation or equation of motion in cylindrical coordinates always denoted by using r, theta and z coordinates may be expressed in scalar form as summation of fr equal to mar, in which ar is actually r double dot minus r theta dot square. If you summation of f theta equal to ma theta equal to m times r theta double dot plus 2r dot theta dot. And another one is summation of fz in this plane. If we are considering the height of the particle travel as well, summation of fz equal to maz, in which az is actually the second derivative of z. So remember that when we are talking about dot here, it's actually with respect to time. So if I say r double dots means that it will be the second derivative of dr over dt. If the particle is constrained to move only in the r dot plane, in which the z coordinate is constant, then only the first two equations are used as shown below. The coordinate system in such a case becomes a polar coordinate system. In this case, the path is only a function of theta. So we can eliminate summation of fz equal to maz. In this case, since they mention here, if the case is z coordinate is constant, we are not means that the particle is only travel in one level. It's not concerning about the height of the motion. So note that a fixed coordinate system is used, not a body-centered system as used in the NT approach. Okay, this is about the tangential and normal forces. If a force P causes the particle to move along a path defined by r equal to f theta, the normal force N exerted by the path on the particle is always perpendicular to the path tangent. The frictional force F always acts along the tangent in the opposite direction of motion. The direction of N and F can be specified relative to the radial coordinates by using angle C. Alright, if you see here P, N, F, N and F here in red color means that this is a vector. So if we refer to this diagram or this picture, this is O means that this is the origin of the particle, while this is P is the force that acting on this path. Okay, the particle is traveling into this path. This is the applied force. So N is the normal force, while F is the frictional force. What we can see, the frictional force is in this directions, means that the particle is actually moving in this direction because frictional force always in the opposite direction of the motion. Okay, if we extend this line or this plane, we actually can take the tangent, the angle between the tangent and this plane as C. While from the origin, as the ground station is here, and plot until reach the angle, the axis of R, this could be the theta. Okay, this is the different determination of angle C. The angle C defined as the angle between the extended radial line. Okay, this is the radial line, but we extend the line here. So we say this as extended radial line and the tangent to the curve. Okay, this is the curve. The tangent is where at what particular position that we want to analyze, and then we need to take a 90-degree about that path, and then we can check for its tangent. So the angle C is actually measured from R radial to the tangent line here. So the angle theta, angle C can be required to solve some problem. It can be determined from the following relationship. Tan C equal to R d theta divided by dr. So if we see here, this is a triangle in which it has been taken with respect to this line. The changes in terms of theta, we said that as r d theta. And then of course, when I have d theta, I need to measure the angle, the distance as dr, the changes in terms of radial direction. So we treat that from the distance from origin to the particle, for example here, as r, the radius, and then this will be known as d theta. And I would say I have this relationship, which is I say this as r d theta. Why is that we say r? You still remember how to find the if we take this the length as a arc length of a circle, I would take the radius times with the angle, so I can measure this distance, the arc length. But here, since this is considered to be very small, so even this is just straight line, we can take that as an arc length. That's why if you see tangent C, this distance divided by dr. Dr is this one. How we measure that? We translate the C here into this triangle. It will be somewhere around here. This is the angle. So we take tangent, the opposite length divided by the side length of between the angle. So with this we will get this relationship. So equal to r, because dr is this one, but we can put that as a denominator by dividing this parameter. So it will be reduced into this parameter dr over d theta. If C is positive, it is measured counterclockwise from the radial line to the tangent. If it is negative, it is measured clockwise. Okay, this is the example in this chapter. Given the 0.2 kilogram pin P, okay, this is the pin P, is constrained to move in the smooth curved slot defined by R equal to 0.6 cos 2 theta meter. The slotted arm OA, okay, this is the slotted arm OA where the inside is empty because it can permit the particle to move as in the slot. So the slotted arm OA has a constant angular velocity of theta dot equal to -3 radian per second. Motion is in the vertical plane. So you need to find force of the arm OA on the pin P when theta equal to 0 degree. What is the plan? First of all, you need to remember that this is the basic in every time you want to solve this kind of question. First, you need to draw the free body diagram and kinetic diagrams. Remember that free body diagram always show the particles and the forces acting on the particles. Only that. Don't mix up with any other parameter. And then you also need to draw the kinetic diagram to show the motion of the particle. Next, develop the kinematic equation using cylindrical coordinates. This one is related to the Newton's second law of motion, summation of F equal to ma. So you need to identify in which direction we have the acceleration. Then next, apply the equation of motion to find the force. So when we want to solve this question, first we need to draw the free body and kinetic diagrams. Please remember that you have to identify the axis. In this case, what is the initial coordinates of this particle? So establish the r and theta coordinate system when theta equal to 0 degree. Is that in this position because theta is 0 degree. And later you can draw the free body and kinetic diagram. So how to identify which one is r and which one is theta? If you see, in this case, the particle is traveling around this loop. So of course, the theta, the r, or we say radius, must be reflect the center of curvature. In this case, O will be the center, so R will be in this direction because this is our radius. So if this is our radius, 90 degree to that axis will be theta. Okay, that's why R is in this direction while theta is the 90 degree compared to with respect measured from the radius to this plane or this axis. And as we mentioned before, we keep repeating about this. The particle, what kind, we need to identify what kind of force that acting on that particle. We understand or we aware that the particle is 0.2 kilogram, means that there is a weight on being applied here, unless the question said this is a weightless or there is no weight at all. But since we have a weight equal to 0.2 kilogram, so I am going to have a weight measurement here, downwards the direction to the earth. And as the particle is laying on an object, we should also identify the N, normal force. So always acting opposite to the weight, or not really to opposite to the surface. All right, we know that kinetic diagram is always concerned about the motion of the particles. In this case, if we reflect back to the r and theta axis, the motion will always acting in AR, SAR, MAR, and for theta, SMA theta. In this question, it's actually they give you the radius is equal to 0.6 cos 2 theta, and then theta dot equal to negative 3 radian per second. If you see the r equation, the radius equation that they give here is in term of theta. So what you need to do is just do this kind of derivation to find each parameter. So summation of Fr equal to MAR equal to M times R double dot means that you have to derive with respect to time. R double dot is dr over dt. Second derivative of dr over dt. And then later you can put it inside this equation. The same for summation of f theta equal to ma theta, means that it is m times r times theta double dot is the second derivative of d theta over dt. So here dot is actually with respect to time. Please remember this. When you see a dot, is actually a derivative or differentiation derivative with respect to time. So just take a look into this equation. You just need to derive with respect to time. So we have r equal to 0.6 cos 2 theta. When we derive that with respect to time, I will say r dot equal to negative 1.2 sine 2 theta theta dot. And later I can use the product rule to solve this equation as well as r double dot. So r double dot is into this form, negative 2.4 cos 2 theta d theta dot square minus 1 over 2 sine 2 theta times theta double dot. Technically, you can separate this as two portion. This is considered as u, negative 1.2 sine 2 theta as u, while v equal as theta dot. So just plug in into the product rule formula, you will get this equation. As in terms of kinematic, at theta equal to 0 degree, it is given that theta dot equal to negative 3 radian per second square. So we know that since this is constant value, means that d theta over dt here is actually a constant, then you want to derive that again, it will give you a zero value. So theta double dot is 0. In that sense, once I know what is r dot and what is r double dot, also theta, what is theta dot and theta double dot, we can just plug in every of the value, and later you can solve this question. So when I plug in as theta equal to 0, I would say r, to find r, 0.6 cos 0 equal to 0.6 meter. So to find r dot, you need to insert the value of theta equal to 0 in this case here, and also negative 3 in here. So you will have r dot equal to 0 meter per second. The same thing you need to apply for to calculate r double dot using this value as well, but you need to include this value theta double dot because there is a parameter that need to be insert here. So r double dot, you will get, once you plug in everything, you will get negative 21.6 meter per second square. Okay, dr over r dot is actually dr over dt, means this is a velocity. That's why you can see here meter per second. R double dot means dr, second derivative of dr over dt, in which it refers to an acceleration. So to find this, once you know what is each component, you can just plug in here ar equal to r double dot minus r dot square. You take this value, negative 21.6, plug in here, and then minus with r, you already obtain somewhere over here, times negative 3 square. So you will have AR equal to negative 27 meter per second square. While the same thing you need to apply for A theta. In this case, R theta double dot plus 2R dot theta dot. So you will have here 0 meter per second square. So basically you already know each parameter AR and A theta. Now you need to apply the value in the equation of motion. For example, in this case, theta direction, summation of F theta equal to MA theta. So referring back to this free body diagram, I will have N minus W equal to MA theta. So N here minus 0.2 times 9.81 equal to 0.2 times 0. Why 0? Because you already obtained A theta from this equation. A theta here. So directly you can get N equal to 9.96 Newton in this direction. Alright, this is the group problem solving one. Given the smooth can C, this is the smooth can C here, is lifted from A to B. A is here, the point A is here, B is here, by a rotating rod. Why they said rotating rod? Because I have theta dot equal to 0.5 radian per second in this direction. So means that this rod has a angular velocity. Okay, the mass of the can is 3 kilogram. So remember, when we have 3 kilogram of mass, we need to calculate the any other forces that acting on the body. So please here, they mention here the condition, neglect the effects of friction in the calculation and the size of the can so that R equal to 1.2 cos theta. So means that R, the radius here will be changed according to this equation. Okay, you need to find the forces of the rod on the can when theta equal to 30 degree and theta dot equal to 0.5 radian per second, which is constant. So remember, when they say constants means dr over d theta over dt. So if you need to do another derivation, since this is constants, there will be d theta, second derivative of d theta over dt will be 0. Okay, first the same technique or the same step we need to apply. First, find the equation, the acceleration components using the kinematic equation. Or this is the second part actually. First, actually, you need to draw the free body diagram and kinetic diagram, and later find the acceleration components using the kinematic equation. And the last one is to apply the equation of motion to find the forces. So just remember these three steps. Draw free body diagram, draw the kinetic diagram, and then find acceleration components, in this case A theta and AR. And later you need to refer back to your free body diagram and kinetic diagram to apply the equation of motion. Okay, to find acceleration of motion, so to find the acceleration, in this case A theta and R theta, the tips is you find all the required parameter first. So they give you R equal to 1.2 cos theta. So you need to derive this with respect to time, dr over theta equal to negative 1.2 sine theta. You need to differentiate inside, you will get theta dot. So you treat to find the second derivative of dr over dt, dr dt, which is denoted as r double dot. You treat this as two parts. This is u, this is v. So you can just use the product rule. Using the product rule, you will get this equation as well. Now you move into theta. So they mentioned that theta equal to 30 degree. You need to find the forces of the rod on the can when theta equal to 3 degree, 30 degree, and the condition is given as theta dot equal to 0.5 radian per second square. So when you apply everything into this equation, basically you have already get the value of theta equal to 30 degree, theta dot equal to 0.5 radian per second square. This one is given, and they also mentioned that this value is constant, so when we want to derive this again, it will become 0. Okay, then just insert everything inside this equation. You will have this value, r equal to 1.0039 meter, and so on. Okay, the target in this part is to find AR and A theta, because this is already given, the formula is already given. You just need to plug in everything inside this equation. Once you plug in the equation, you will have the value of each parameter. AR equal to negative 0.51696 meter per second square, and A theta equal to negative 0.3 meter per second square. Okay, doesn't matter if you want to draw the free body diagram later after you have, because this is just the value. But if you want to draw the free body diagram, also can. Okay, this is the parameter. Sorry, the particle. So they mentioned that there is a weight as 3 times 9.81 Newton pointing downwards, and also the can is lying on a surface. Of course, I have N. Okay, it travels somewhere over here, so means that actually we also have friction force. But since they ask us to neglect the effect of friction, so we can just neglect that equation. Okay, so the particle is actually travel in this direction. So frictional force should be in this direction. But the force, they ask us to find the force. Find the forces of the root on the can. So the force that been used to lift up this can from point A to point B. So we can say this as F. So I have F somewhere over here. And of course, R direction is in this direction, since it gives you a curve cylindrical motion as in this direction. So pointing towards the center of curve. Okay, and then kinetic diagram just show the direction of the motion of each parameter, AR and A theta. Now you need to apply the equation of motion. Summation of FR, you need to refer to this direction, equal to negative 3 times 9.81 sine theta. So you need to resolve this in this direction. So I will have downwards direction somewhere over here. That's why we said negative. If you want to resolve with respect to this angle, 30 degree, plus n cos 30 degree. So resolve this in this direction, you will have a positive value in this direction. That's why I put that as positive n cos 30 equal to 3. Okay, this is MAR equal to M3 times AR. You already obtained that from this equation. AR is negative 0.596. Okay, later just go for summation of f theta equal to a theta. You repeat the same thing. F is in this direction, so of course it will be positive. And then let I also have n. I resolve this in this direction, positive. Because this is a vector, so you need to resolve that into components. So I have n sine 30 degree. This is the opposite direction. Okay, minus 3 times 9.81 cos 30. Okay, the way is pointing downwards towards the earth. So of course, the direction of f theta is in this direction. Okay, that's why I put that as negative 3 times 9.81 cos theta equal to MA theta. So MA theta, M is 3 kilogram, while A theta, you already obtained that from this equation as well. So resolve this equation, you will have N equal to 15.2 Newton and F, the applied force on the road, equal to 17 Newton. Okay, this is the end of this lecture. Thank you very much. Any question raised, we can discuss that in our session. Thank you very much.